sorry, I'm interrupting you. The answer to almost all of your questions are gonna be answered when I start cranking out problems. Okay? But I wanted to lay like a structure, a skeleton, and then we're gonna start fleshing it out. And so, some of your questions, like Anya's, I'm gonna maybe get her to write it down at the top of her page or something. So if I call on Bren and then all of a sudden I go just wait, please write it down in case. I think at the end you'll all be able to scratch out your questions and go, oh, she answered them today.
Just since I'm leaving, can I just ask this quick one?
Yeah.
Okay. So what would an IBM look like on a graph?
It's EBM, isn't it?
Yeah.
EBM. Sorry.
And behavior model. I think we'll just use these white slides because they're here. I can't do that. That's against my religion. Okay. So, and I think it's recording. We'll do baby picks one. I don't know whose these are. Just hope one of your sisters didn't turn yours on. We'll see. I should have took.
That's amazing. Who is that? Linda?
I should know who that is, but I can't remember.
That's Morgan.
Is that Linda?
Yeah, I think so.
I think it would be Linda.
I think that's
That looks
Linda.
like her.
I think that's Celine. Yeah. Let's see. That may be still Celine, I'm not sure. Is that Carla? I think it is.
Yeah,
I think
that's
that's,
Carla.
That's so cute. So cute.
I think that's still Carla.
Yeah, so cute.
Yeah, lots of Carla.
That's Romy.
And then there's like math. Okay. So, all right. Let's answer Bren's question while she's here. And so if you will go to your graphing worksheet, and Bren, I'm just going to check and see if there's one on here that I can show that to you. There's not really one on here, so let me pass this out. Something we're going to go over today anyway. So if you'll quickly make sure you get a front and back, okay? And when it gets around, just leave it 2:15.
2:20.
Okay. I hope there's one under here, Bren. Let's see. Oh, whoa. I hope I did two. Did I print the same thing on both sides? Or do you have a different one?
I can't print.
I have 6 different columns altogether.
Okay, so, oh, Bren,
I
there's
started
not
my
one
vitamin
on
K
here.
supplements today, and I need to see if I'm responding.
Okay,
to them.
so I'm gonna make one up. So, just somewhere maybe on your worksheet I just handed you, why don't you call this number 6, if you have a little bit of room at the end to put it.
I don't know. Is it a front and back?
Huh?
You got it back.
I got it back.
Don't worry.
Did everybody get a front and back?
Yeah.
Alright, I'm gonna shrink Linda. Alright. Okay, so let's say if we have y equals x cubed minus x squared plus 2 over x minus 4. Alright, let's go through our list of things. By the way, on this sheet,
I don't have one.
oh, sorry. Is there an extra one? Here, this is yours. Okay, sorry about that. You'll have a list of things to check that I'll probably even write on there. You won't ever on any of them fill in every blank. It's just I'm gonna check, is there a hole, is there a this, is there a that, okay? So, first of all, let's decide if there's a horizontal asymptote, and there's not, because the top's bigger than the bottom. Common sense tells me that's just gonna go off eventually to somewhere else, because it's gonna get bigger and bigger and bigger, or smaller and smaller and smaller. All right, vertical asymptote, anybody?
How do we?
What is the vertical asymptote? It has one. What is the vertical asymptote? X equals 4, because do you see how it falls completely apart because you can't divide by 0. So you can never put in 4 here. You better not call it a vertical asymptote yet though, because I gotta check the top.
So we just,
So let's fill 4 into the top, and I get 64. You may not know what 4 cubed is. 64. You'll have your calculator the whole time.
minus 6.
Plus 2. That doesn't way it's going to get to 0, does it?
No.
So I call that a vertical asymptote. And so does this one have a hole in the graph?
No.
It could have both of those. This one does not. Okay. It doesn't have a slant asymptote, does it? The top would have to be 1 higher than the bottom.
Yeah.
Okay. But I am going to use the fact that I see this right there reduces to x squared. Do you see my highest powers? Reduced to x squared, and I'll use that in just a minute. All right, now you may want to follow along with your calculator or just watch me with mine. There is no hole in this.
Yeah, but how do you find one again?
Oh, you're going to have to wait till we get to one where there is one, okay? Because if I just start talking about it, it's just pie in the sky until I like, here it is. I promise I'll show you.
But how do we know this one didn't have one?
Because I didn't get 0 over 0.
When you plugged in 4 to make that 0, and then you did that there, then that would be 0.
So you,
0.
so we want to check to see if it, so we know the vertical asymptote is just, we just find that by setting the bottom equal to 0, right?
Yes, that, and then double check and make sure the top is not also 0.
Oh, okay.
Okay.
If it is, it's a-
I got something big over 0, okay? All right, now, I'm gonna type in my function I made up. Some of y'all wrote it down, so you'll have to,
X cubed.
okay?
Minus 2x. X
squared.
squared, sorry.
2x squared
No,
No,
just
X
x
squared.
squared.
Oh,
two,
no.
sorry.
Minus x squared plus 2.
over x minus 4.
Yes.
All right, it's real important, y'all all know this by now, to put this in parentheses. I'm just gonna tell you that you will most likely, you could easily fail the test if you think you're just gonna type them all in and hit graph, okay? I'm not even gonna hit graph right now. I don't even care what it says because it can be so misleading to me. I care a whole lot more about table right now. And so I'm gonna go to table and I'm gonna fill in some things. All right, so I draw as I find things. I have a vertical asymptote at 4. In fact, let me move this over because I'll run into problems over there. All right, so I have a vertical asymptote at 4. Problems over here too, but it's not very oriented, but I tried to go through 4. Okay, you will go through 4 on test day. Oh, that's all I have. I don't have a horizontal asymptote, I don't have a slant asymptote, so now I'm a bit unsettled. What will happen many times, I hope it happens here, I don't know if it will, because I just made it up. Many times I'll hit graph and you'll only see one piece of the graph, because life doesn't live in a negative 10 to 10 viewing window, okay? And so many times, I never want my students frustrated. I don't want to challenge you, but I don't want you frustrated and confused. You can ask table, you might be sitting there on the test, and if you're thinking, I wish I could ask Miss Lazari where this is, or I wish I could cheat and ask my neighbor where this is, ask table, where are you? It's easy enough just to go, I don't know where this graph is. I can find out. So I'm going to go back to my calculator, which I guess is back here. Okay, and so I'm gonna start asking table. I've lost the slides we were on, I'm sorry. Oh, it's these, isn't it? Okay. All right, so, sorry about that. I'm gonna go to table and I'm gonna put in, like 4 is gonna give me undefined, right? 5, I'm starting to get points really fast, but hello, it's at 102. And I do expect you to draw things to scale. So you might have to go 10, 20, 30, 40. Let me keep on going. I'm gonna fill in 7. All right, I'm just gonna leave that alone right now. I'm gonna go back before 4. Do you see it's broken at 4?
Yeah.
So it makes sense to look at before and after. I'm gonna fill in 0, and I get negative 1/2. So 0 gives me negative 1/2. And then I'm gonna fill in 2, and I get negative 3. So 2, negative 3. And so I'm guessing when I look at it, this is gonna come through kind of like this. I know I have more experience in it than you, and you're like, I didn't guess that, okay? And I may be wrong, but I have the ability now to look at my graph and look for more points. The beauty of me setting your table up that way is you can crank out 20 points in 20 seconds, okay?
Thank you, Mrs. Zara.
All right, and try to, Bran, watch it from here, okay? So you see
Watch
it.
the rest of it.
Okay, bye. This is a great one. I'm glad I did this. This is as hard as it can get, by the way, if you're thinking, well, she's just started doing problems and oh my gosh. Okay, this is as hard as it could get. Yeah, so there's the graph. Many students that are not of your caliber would draw that on their paper and go on. This is really the answer to Bryn's question. Where does my end behavior model come in? I go back and I go, I'm smart enough to know it's undefined at 4. Therefore, it is defined everywhere else, right? So it's somewhere out there, okay, because it exists. Also, I know that in the end, when I back away and look at Darth Vader, that's going to look like an x squared. So I know my end behavior model, you wouldn't draw this on there, but my mind knows that eventually it's got to go like that. Do you see how I know it's going to be a sweeping x squared graph? You know what x squared looks like? Okay, also, we have that little insider information that 5 was up at 100, okay? So I'm going to redraw this graph because I do require that you're drawn to scale. I can't send you out in the world telling people, you know, like, oh, well, here's your investments, and you started at $10,000, and now you have $1 million. They'd be glad to know it, but they also would probably fire you and take their $1 million and go somewhere else because when I get reports on my extremely measly investments, it's drawn to scale, and it better be. Do y'all see what I mean? I definitely want to see that $1 million way up. I don't have $1 million. I mean, so, if I had $1 million, I would love to see it way far up over $1,000. Do y'all see what I mean? So you are required to draw it to scale. So what I'm going to do is I'm going to go back for a minute and count by 1, 2, 3, 4. I'm going to count by, let's see, 5, I'll only need 20 of them. Let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, okay? 0 was -1/2, which is really hard to show. It's about right here, it's a little bit closer to 0. 1 was, does anybody remember what 1 was?
-3. No, just kidding, that was 2.
Okay, that's good. 2 was like a little closer to -10.
1 was -0.6.
Thank you. So it's still really up there close to 0, okay? If I'm counting by tens, those are really hard to draw. What is 3? Those of you, did anybody put it in their calculator and can tell me through table?
3 is -20.
Oh, good. So that makes it easier for me to graph. That's awesome. Do you see if I've drawn this scale? You can find a few more points and you know your graph looks like this. And then I hope none of my students just like leave and go away because I know there's something over here because of my end behavior model and because of my reasoning. I remember when I put in 5 and 7 that I got way up around 100. So there's also points way up here around 100. You could find a few of them. And the rest of the graph is going to do something like this. And so you don't draw this part in there, but y'all see my end behavior model? If I back away, I kind of lose this detail, but I see the 2 arms of it. I'll show you on my calculator, and then I'll let you ask questions. Whoa, that was extreme. Okay. So you're the one with the brain. Your calculator does not have a brain. It is a tool in the hands of your marvelous brain. We know that the top is 2 higher than the bottom, so it has to eventually go off to positive and negative. In the positive and negative direction, it's going off to infinity. You can ask table, where the heck are you? By filling in like 5 and 7, and it goes, well, no wonder I don't see it. So now I'm going to go to window, and how am I going to make myself feel better before I go to the next problem? Wouldn't you like to see it? So what do I need to change my window to? You already know from your friend. Table. What Y max do we need? Or maybe give us a little room. Let's go 120. Interestingly enough, if you want to, you can even count by tens like we did. If you want to see it like your picture on your page. Is that a 10?
Yeah. How do you get there again?
Wow, that was
Press
weird.
Second, or you
Does that look weird? Okay. Window. Like I want to look out the window. Okay? So now I'm going to graph. Okay? So how'd we do? Should be able to grab that. And it was going to be really fancy and very impressive. There we go. All right, so we did good, didn't we?
I'm a little confused.
All right, hang on just a minute, Anya. I'm sorry. Hang on. Okay. And I've got this all in my writing, but I hope you can see it's the same graph. My lesson here is this. I knew that it had to look like some sort of x squared graph in the end from an airplane. I knew its in behavior model was x squared. Sorry. I don't even know what I just did. I hope I didn't clear like everything out of the calculator. Yeah, as much as we can hear them, they could probably hear you. Do y'all see how that pattern is pretty good for this graph? I'm not gonna
put it to make it do that.
X squared, just a little bitty old x squared as a pattern for that intricate graph. I'm not going to do it right now in the interest of time, but if I start zooming out on that, the blue and the red are going to merge more and more together. If from an airplane, I'm not going to even see all this mess in here. I'm just going to see these blue arms going off, okay? All right, let me take a few questions, but I really need to just hit problems. Anya?
What is that thing in the corner that we, like the little,
That's part of the graph.
are we expecting
I filled
to
in,
know
yes,
how to draw
absolutely.
that?
That's why I just spent 10 minutes on that last part. Absolutely. When I say graph this, I mean graph this with your incredibly smart brain. Like, don't leave that undone. Don't just go, oh, I'll just only graph the part up to 4. Why wouldn't you graph the part after 4? Which one's more important? I don't know. Like this is the graph right there. That's the graph. Okay, so if you don't graph it all, I'm going to count off. But of course I would expect you to graph it all, okay? Think about real life graphs that I started class with. Real life graphs are really funny looking. I bet if we graphed, you know, if you, and even think of a heart rate if you look at it. You know, and sometimes if it goes, you've heard of off the charts? Doctors pretty much need to see that. Somebody better adjust the window so they can go, where is it off the charts? Like, oh my gosh, when they test you for things, your anemia could be flagged, if you have cancer or something can be really low, and they go, whoa, I don't see the picture of it. I want you to find it, okay? I'm sorry, I always use deathly horrible examples. I need some happy ones. To be such a happy person, I don't know why I use such horrendous examples. Yes?
So basically, every time we do this and we need to graph it, we put it into our calculator and put in like how many like what if there's a number that we put in, like we can't, it's obviously we can't put in every number. So like
I tell you
what's the
what,
limit
I'm
to
just
it?
gonna start cranking out problems and we'll see. You won't have that question in a few minutes. Ready? All right, so get out your homework and let's look at, let's start just for now with number 4. I'll probably go back to some of the others. Okay, so check your work, but also I'm going to be answering your questions as I go. All right, so this is number 4. Number 4 is y equals 3 over x plus 2. I'm going to go at a nice steady pace, but I'm going to keep pushing, okay? This is what I would do. I would go, I'm not going to ask you domain, but it's a good thought. Y'all know -2 is not in this domain. I know Nazareth had said that.
Yeah.
That just helps you know the vertical asymptotes and holes, okay? I'm not even going to ask you certain things, probably on your test. I haven't made it out yet, but it usually looks a lot like this. On the first page, where I just give you a suggestion of things to check. If you don't want to check them, that's fine with you, because I'll be grading your graph, like Anya was asking, okay? But so most of us, in fact, I'm gonna kinda go offline here and I'll kinda go in order. What I would do here is I would check for vertical asymptotes, cause I think Nazareth and I know that, and I just have talked to her about it, the rest of you I hope know also. We're checking domain while we're finding the vertical asymptote, it's all the same thing.
Are vertical asymptote and domain the same thing?
They're the same thing. I mean, vertical asymptote is where the domain can't be.
Vertical asymptote can be.
Like your domain is all real numbers except
So since
negative
we
2.
know the VA is -2, we
X
know
is
it can't
negative
be
2.
-2.
So now we know that's not in the domain. It's badly broken there.
Okay.
Alright, my vertical asymptote is -2. I strongly suggest that you start graphing as you go, as you find things. I think I'm gonna have to just draw a little smaller. X equals -2. That's supposed to be through -2, just pretend like it is. I'm so sorry about this board. There is no hole in this graph, I should think about it, but -2 is the only thing that makes the bottom 0, but does it make the top 0? No, okay? So there's no hole, that's fine. I don't really care if you find the X and Y intercepts, quite honestly, but if you know how to do it, it goes back to Dakota's and Anya's question. At least that gives you 2 quick points, but if you don't want to find those particular ones, I don't really care, alright? It's always a good suggestion, and your Algebra 2 teachers trained you for that a while back. I'm going to horizontal asymptote. I would say this one's bottom heavy, so the horizontal asymptote is Y equals 0.
But it doesn't even have any exponents.
Yeah, this is x to the first. So if I have 3 divided by, x is gonna vary, that's why it's called a variable. I don't know whose voice that was that your voice? You doesn't have any exponents?
Oh wait, I did say
Okay.
that.
Do you see that it does?
Yes.
X is called a variable. I mean, there was some aha moment in, unfortunately in high school that I went, oh, I didn't realize that's what it's called, a variable. The other 2's, the 3's and the 2's cannot change, right? They're constants. But X is gonna change, and if I start putting in like 100, 3 divided by 102, if I brought in 3 cupcakes and I've gotta feed 102 people, you're gonna get a crumb, right? Do you see why this one's going to 0? It's bottom heavy. Okay, it has an exponent, the top does not have an exponent. So the bottom's bigger than the top, okay? So it's Y equals 0. Now, one thing that is not written down yet is it can actually cross the horizontal asymptote. From some teachers, people think that you can't touch an asymptote, and you can. You can cross right over it. You can try to get away from it. You're gonna, hang on, write your question down. You can cross an asymptote. It's not that rare. You cannot cross a vertical asymptote. Your graph is broken there, okay? This one's just like, hey, follow me over here, okay? Like the dotted lines in the road. All those dotted lines down the road, on roads that have dotted lines in New York, some of them don't even bother. But the taxi's allowed to cross the dotted line and get in a new lane, right? And then they still just have to drive between the asymptotes. It's okay to do that. All right, so you can check for cross by saying 3 over x plus 2. Is it ever gonna cross 0? Let me show you what I just did. I just did substitution. Do y'all see a y right here? You see a y? Do you see another y equals?
Y equals 0.
So do you see how I just subbed that in? I just plugged in for another y. And now I'm gonna cross multiply. And I get 3 is equal to 0. Is that true? 3 doesn't equal 0, does it?
No.
All right, so you know what that's trying to tell you, that little math? It's trying to tell you it doesn't cross, which is good news. It helps you graph it. If it doesn't cross the asymptote, you have less work to do, okay? Now I have a vertical asymptote and a horizontal asymptote, and I'm ready to find points. So I haven't put this one in my calculator. A couple of you might scramble and put it in your calculator. I'm gonna try to do some in my head. At 0, I get 1.5. At 1, I get 1. And so it sits in these 2 asymptotes like this, but it goes, let me draw it over here. I'm gonna draw it right here. Y'all help me remember the information that I got. Apparently the center of the board is the most oriented part of it. All right, I have a vertical asymptote at -2. This is good. I have a horizontal asymptote at y equals 0. Now I know everything I need to know. I'm ready just to find a few points. And the asymptotes will help you. You don't have to find a million points. That's why you learn about asymptotes. I call these little pockets. Do you see these pockets? Something's gonna fit in these pockets, okay? 0 crosses at 1.5. I filled in 1 and I got 1. And these asymptotes are gonna guide me along. Do y'all see what I mean?
Mm-hmm.
Is there something back there, even if I don't see it on my calculator? There has to be. How can you find out where it is? You can go to table and say, what's at -3? What's at -4? You can start to ask your calculator, okay? This one you do see, but your graphing calculator could do some really bad graphs. Don't draw bad graphs on your test. Draw good graphs on your test. You're the one with the brain, not your calculator. If you fill in -3, right on the other side of the asymptote, you get -1. And I would find a couple of more points, but you'll find that it does this. And most of y'all probably have that graph on your paper. I'm gonna go right to number 5. We've gotta get that one done before we leave. Let's go to number 5. I'm just gonna do a white thing. We've seen a lot of babies. Okay, so we have y equals x² minus 9 over x minus 3. Most of you, I think, know that that factors into x minus 3, x plus 3. I don't even know why I went over there, anywhere close to the edge of this board. Would a couple of you go on and be putting this into your calculator? X² minus 9 over x minus 3.
That's right.
Okay. Now let me pause because I'm flying. Are y'all okay with my factorization of the numerator?
Yeah.
Okay, x² minus 9 is x plus 3, x minus 3. And this cancels. So my graph's really gonna look like x plus 3. This graph and that graph are gonna look exactly the same except for at one point. The point I just threw out. Okay, so let's go through a list of what I would look at. I would look for a vertical asymptote. My first thought is that it's at x equals 3. Watch this. However, it is not. I thought it was 3, but then I filled it into the top, and what did I get? Fill 3 into the top.
0.
It makes the top 0. So now you have 0 over 0, which means it must be a what?
Hole.
A hole. That means I just poked a pencil through my dress. I didn't tear it up, okay? So this has a hole in the graph. At 3 comma something, you have to give me where the hole in the graph is. There's a couple of ways to figure this out. Does anybody have this in their calculator? All right, so Nazareth and Alex have it in their calculator, and Dakota, thanks. So you'll have to trust them. Always, girls, make sure you put the original question on the piece of paper, not your reduced question, okay? Do you have that one?
That one?
That one?
No.
Yeah. Because this is what you're graphing, Dakota. You don't want to do any of your algebra, you don't want to type into your calculator. All right, I'm gonna get everybody that's ready with their calculator to go to table and put in 3, and you'll get error. Is that correct?
Yeah.
Nazareth, you got error? Oh, you gotta make sure you hit the minus sign, not the negative. I can't believe I figured that out. Make sure you put the minus sign. All right, so we have 3 error. So Kate and a few of you others are like, I don't know how to find the hole. Okay, she didn't say it like that, but I know you're all like, come on. All right, so the hole's at 3, so I can't go there, but it's microscopic. So I'm gonna get Nazareth and Alex and Dakota to fill in 2.999. Something really close to what? 3. Like this hole in my dress, and there's something that's right really, really close to it, right before it and right after it. I bet you get something really close to 6. Do you get like 5.999?
What number?
I said 6. I said 6. Maybe.
What number are we filling?
Okay, if yours actually says 6, girls,
2.999.
take your arrow and cover up the Y column, like this.
What are we filling?
2.99. Oh wait, yours doesn't say 6, yours says 5.999.
Yeah, that's what ours
But I
says. Mine
rounded it
says
to
too.
Yeah.
What does yours say?
5.999.
5.999 too.
Where does yours say 6, where is it?
Here.
Okay, so I'll see what you pulled in. See, I can actually cover it up, you just went even closer to 3, and you're really getting that number, but it's having
I
to round
see.
it off,
Okay.
okay? So anyway, you don't have to get ridiculously close, but you'll get close and go, oh, this is getting closer and closer to 3.6. Your other option, watch up here, thank you for taking notes, other option, in a class like this, it can get tougher, but what I'm gonna test you on is you can factor and cancel, and this will look exactly alike except for at this point. I'm gonna explain that real quickly, okay? Can 3 go into that graph?
Yes. No.
Because you'll get what on the bottom?
Zero.
Can 3 go into this graph?
No.
That one?
Yes.
Because I canceled,
Zero,
right?
but you would still get 0 through 0.
No, but I canceled this, I'm sorry, can it go into this?
Yeah.
one?
Yeah.
What do you get? 6. Okay, so watch this picture. Alright, so I forgot what I have. X squared over 9. I'm sorry, x squared minus 9.
Do x squared minus
Thank you, Dakota, thanks. Always make sure you hit the minus sign, not the negative sign. I'm gonna get it right in a minute. Okay, x squared minus 9 divided by x minus 3.
Wait, so if there's a hole, there's no vertical asymptote?
You can have both, but not at the same point. We're gonna get to some Friday or that have like, you factored them and there's 2 things that make the bottom 0. You could have 2 vertical asymptotes, one could be an asymptote, one could be a hole, they both could be holes. They're just undefined there, you gotta find out why. Okay? Alright, but you can't have a hole and an asymptote in the same place.
Okay.
Either I have a hole in my dress or I'm gonna throw it away.
So 3 can't serve as both, it has to
3
be.
cannot serve as
Okay.
both, you have to make a decision, okay? Alright, now, I want you to watch this carefully. I think I showed you something similar to this the other day. That's what I want you typing in your calculator. But after we factored and canceled, we got y equals something easy like x plus 3. Alright, I am going to turn, I think you can see them both. I'm gonna go to Zoom 8 and hope that this works. This is the blue one. This is the one on your paper.
Zoom 8.
You don't have to do that. In fact, it didn't even work, so I'm gonna stop it. If you wanna stop your calculator, if I taught you how to do that,
No.
don't you hate waiting for it to keep
Yeah.
graphing when you wanna change your mind? You hit the home button like this, and it'll just stop what it's doing, okay? You don't have to be able to do this. This is just a teaching tool. Let's see. Now, when you get to number 5 and you look at it, doesn't it look like it should be one of those? Okay, what? That was unfortunate. All right, so. All right. When you look at the paper, number 5 doesn't look anything different from all the other crazy stuff that I've done. But now when I graph it, it looks so simple, it's scary. It just looks like a good old Algebra 1 line, doesn't it? So blue is on your paper, and I want you just to sit and watch, but all eyes need to be on the screen. The blue one has a what in it? A hole in it. The red one is exactly like it, point for point, except for how many points? 1. So do you see the red one can serve as a model for your blue one? But what do I want you to show? The hole in the graph, okay? By the way, how much higher is the top than the bottom?
In what is
Always on the original.
one
You're-
degree.
It's 1 degree higher, so this should have a what asymptote? Normally, what do you have to do to find a slant asymptote?
Divide.
Which you could do, but guess what you would get in this problem? Do you see how it's slanting off?
Yeah.
Okay, so this is an obsessive compulsive graph. We need to send it somewhere, okay? What that means, if I go, Alina, follow me, and she gets up because she's so obedient, she follows me, okay? And I go down the stairs and, go get some M&Ms from the religious studies office, and me and Alina are going around the room, okay? But if I got somebody that was really rigid in my instructions and I said, follow me, they would be like right on my tail. Especially if we were walking in the snow, they would be like, I'm gonna step in her footprints. This graph is going, follow me, y equals x plus 3. This is my slant asymptote, okay, that's my slant asymptote. That's the only asymptote I have. And usually you're used to things curving all around and eventually following. What happens right now though is that this graph comes in over here. I'll call it the red graph. And it follows it step for step for step, except for at 1, 2, 3, what? Good. You've got to leave a hole in it at 3, 6. That's why I wanted to make sure I get to number 5. It's kind of a weird graph. Most of you in this class would have also done long division because the top's one higher than the bottom. You may not have thought to factor and cancel. This one's a bit different. I'm probably not going to do another one like this. We might, okay? All right, now, let me see. I think we're good. I think I've done a lot of explanation for you to be able to try your homework. I tell you what, let's do this because I've got this backlog of problems I want to do with you still on Friday. We got a lot of good stuff done today. Why don't you try 1, 2, 3 on the worksheet I just handed you, and I'll post that on the assignments. So do 1, 2, 3, and you do not have to do 4 and 5. We'll do it together. And you have all the way till Tuesday to ask questions after Friday. And depending on how far we get, I hope we'll get really far on Friday, and I won't show you silly videos and pictures. If I have to, I'll do some more examples and send them to you through video, okay? All right, let me turn this off, and then I'll answer other questions. Sorry about